Our title is The Smart Garage, and in a way we're sort of poking fun at a lot of the industry buzz that talks about the smart house and the smart office and the smart grid and the smart this and that. And what we've recognized in the course of our research and consulting work over the last few years is that there's a convergence and a synergy between the vehicle fleet using advanced technologies that we're starting to see, and buildings, and increasingly efficient and green buildings that we work on every day, and also the power grid. And the place where the vehicle fleet and the buildings and the power grid come together are the garage. So it's the smart garage that represents our understanding and our evolving excitement about the integration of the parts of the energy system that we think have very powerful synergies and benefits. So I'm going to kind of introduce this idea in my remarks, and I'll be followed by John Waters, my RMI colleague, who will focus more on the vehicles and in particularly the battery and the electric components of advanced vehicle technology. We'll be followed by Bob Howard from Pacific Gas and Electric, as Ginny said, an award-winning utility. And in fact, when we work with utilities in the rest of the country and we explain the most environmentally sound energy planning practices, it's always PG&E that is the example. The problem is when you're in North Carolina or Kansas or someplace and you refer to an example from California, they sort of roll their eyes, and so you have to sometimes disguise it a little bit when we're bragging about you guys. And then finally, and they'll talk about Bob will talk about the grid aspects in more detail. And finally, Clay Nessler, our colleague from Johnson Controls, who's one of the leaders both in automotive but also in building efficiency technology, will focus on controls and the smart building part of the smart garage system. Well, I want to start with the growing concern on global climate change and the evolving need for reductions in greenhouse gas emissions, particularly CO2, with the simple observation that 6 years ago, the United States government withdrew from the UN's Kyoto Protocol on climate change, which would have committed us to binding emission reductions in the years 2008 to 12, with the argument basically that studies were showing that the economic cost of the US economy would be too great based on studies showing that it would require something like a $50 per ton CO2 emission tax. Well, I don't know if anyone's noticed since 2001 what energy prices have done, but if you add up the numbers and convert them to the equivalent of CO2, we've actually been paying a carbon tax of about $80 to $150 per ton. In other words, we've gotten the economic penalty. We just haven't gotten the targeted policies and programs to mitigate emissions. So what we're really going to focus on tonight is what the private sector is doing in advance, for now in absence of, and at least eventually in advance of federal action. I think Bob's going to talk a little bit more about where greenhouse gas emissions come from, but I just want to make the simple point that about 3/4 of our emissions come either from the power grid, that is generating electricity for its various uses, or from the vehicle fleet. And those are actually the sources of greenhouse gas emissions that are growing the fastest. Now, one thing you're going to hear a lot about tonight from all of us speakers, actually, is the idea of the plug-in hybrid electric vehicle. Could be a car, it could be a truck. But the basic idea is that you take a hybrid vehicle, and the Toyota Prius is the most familiar one today, but there are others, that uses a combination of electric motor propulsion and combustion engine propulsion, using a liquid fuel like gasoline, to run much more efficiently than what we can do with conventional gasoline vehicles. The plug-in aspect, though, means that you can derive power from an additional source of energy, namely the electric grid, by plugging the vehicle in when it's parked, charging a larger battery energy storage component, and then being able to drive not only in the hybrid mode, which is more efficient than just with gasoline, but also in an all-electric mode, where you're not even using the combustion engine at times, particularly when you're going moderate distances and moderate speeds. It stops short of an all-electric vehicle, which we've also experimented with, in that you don't have to be able to charge the vehicle up with the grid just to go anywhere. You can drive with either or both electricity charged in the battery and or the fuel in the fuel tank. So the range is actually the sum of your all-electric range and your fuel tank range. I'm not going to go into the details of the plug-in hybrid design. You'll hear more about that from the other speakers. But it's an important piece of the energy system in that it's bringing together these different parts of the energy system that meet at what we call, a little bit tongue-in-cheek, the smart garage. So as we think about big picture strategies to reduce CO2 emissions in the vehicle sector, there's sort of three basic approaches. And one that we work on very much at RMI, and that you've probably heard Amory talk about in our Winning the Oil Endgame work, is what we call the platform efficiency, making vehicles lighter and more aerodynamic, and thereby reducing the load on the engine and reducing the fuel consumption. Another part is making the powertrain, the propulsion system itself, more efficient. And a lot of the progress in doing that comes through electrifying it and using electric power more of the time and smoothing out the varying loads on the engine. The third approach is using cleaner fuels. Biofuels that can be made from renewable sources is one approach. The other is using electricity, which can be made from a whole variety of sources, including renewable ones, and therefore lower CO2 emissions. And the idea of plug-in hybrids actually contributes to 2 out of 3 of these approaches, in that it makes the vehicle more efficient to drive, even more efficient than, all things being equal, than today's hybrids. As you add more battery capacity in a plug-in hybrid, you actually improve efficiency further. It also gives you much more fuel flexibility and the ability to use any source of liquid fuel, including biofuels from renewables, and any source of electricity, including renewable sources of power. So the plug-in hybrid helps in both those areas, and one of the keys to making that work is actually the first area that I mentioned, that is the vehicle efficiency, the weight, and the aerodynamics, to make the whole package more efficient and cost-effective. And John will talk about that more. Now, if we go over to the other side of the energy system and the power sector, again, there's 3 basic approaches to reducing our CO2 footprint. One, and again, an area we work on very actively here at RMI and with our colleagues in the utility industry, is more efficient energy use in all the things that we do in buildings and industry, be it lighting, heating and cooling, process functions in industrial plants and so forth. Another is, that's very important to the utility company in particular in their cost structure, is shifting demand away from times of peak demand, because it's that time of the maximum demand when not only are emissions high, but that's what drives the cost of power and the need to build power plants, power lines, et cetera. So it's a very important strategy to worry about the timing and the variations and the dynamics of power demand. And then again, the third strategy in the power sector is to use cleaner and preferably renewable sources of power, of which we have quite a few, solar and wind being the most promising at the moment. And again, plug-in hybrids vehicles can contribute to 2 or 3 of those strategies, which may not be so obvious. How does the plug-in hybrid affect emissions in the power sector, which is the sector that's providing some of that energy to the vehicles? Well, first of all, it can, and we pretty much assume and will probably require, that much of the power supplied to plug-in vehicles is provided during off-peak times, like the middle of the night when the cars are parked. And that makes sense both because you know that you're not going to need the car at that time, or the truck, but it also means that that's when the lowest demand is on the grid, costs are lowest, and the most capacity is available to provide power. It also means that you have more flexibility of what power sources you use because of the fact that you're storing electricity in those batteries. You can charge when you choose, and generally that means during off-peak hours, but it also means that you can adapt the use of electricity to the supply of variable sources like renewable energy. And I'll give you an example of what I mean. But the bottom line is that the plug-in hybrids can actually help us use electric power more efficiently and encourage cleaner sources of the generation of electric power, which is a very important thing because we're seeing rapid advancement in the technology for generating electricity from renewable sources, especially wind power, which we now have something like 75,000 megawatts. I mean, that's like about 50 giant coal plants worth of electricity coming not from coal plants, but from wind turbines all over the world, a lot of them in the United States, a lot of them in Europe, increasingly in Asia, in China and India. And we also have rapid progress going on in solar energy, not in as large a scale as wind, but coming along at a comparable pace. The problem with renewables, and particularly wind, is that the output is variable, and it's not entirely predictable. With solar, it's pretty easy. You know when the sun's going to be up. Wind, it's a little bit more random. And so there's a limitation to how readily you can use that energy in driving the power grid, except that if you can increase the amount of storage or the flexibility of when you use power, it makes it easier and more cost-effective to use renewable energy. So what's going to happen then if this idea of plug-in vehicles matures and we start to connect the vehicle fleet into the power grid? Well, the first thing we've observed is that there's going to be an additional need for electricity replacing liquid fuel in those vehicles. And it's probably going to be used during off-peak times, and that's a good thing. It will probably require some pretty significant changes in how utilities serve us as customers, because they're going to want to ensure that we do use the power during those off-peak times. And that's going to mean they will probably install meters that look at not only how much power you use, but when, time of use meters they call them, and billing will be based on that as well. And there's a lot of grid system controls and so forth. The thing that will probably cause in terms of their system is more load at night, more load during times of minimum demand. And today, that additional load will probably be met with the oil and gas, not oil, the gas and coal-fired plants that they wouldn't otherwise have to use at the time. It would still be from fossil fuel. The net effect would still be to reduce emissions compared to using gasoline, but it would still be fossil fuel. The interesting possibility, though, is that we might be able to use that additional load to admit more renewable power into the generation mix. Another interesting possibility, and again, you'll hear more about this later, is that once you have all of this energy storage in the form of batteries on all these vehicles, it may become possible to put power back into the grid when you need it most, during the times when power demand is high, people are running air conditioners and what have you. And to actually use this energy user as a source of power when you need it. We refer to that as vehicle to grid, V to G technology. So there's a very significant change in the dynamics of the electricity system. Let me give you a little thought experiment to explain maybe in pictures what I've been only partly able to explain in words. This curve is the California gross electricity demand for one summer weekday. That's the time when their electric plants have to work the hardest. And you can see it sort of peaks in the afternoon when all those air conditioners are running. Very high power demand, 40,000 megawatts in this case. Now let's just say that we connect 5 million of these plug-in hybrid vehicles. And what that causes is the yellow line, which means that if we're successful at controlling the charging of these vehicles to do it mostly off-peak, we raise that minimum load. And one of the dynamic effects is that should allow us to actually admit more renewable energy at the margin to the power grid, which is a good thing. We can provide more of that additional demand with cleaner sources. Well, let's just take the experiment one step further and say, well, what if we take 60% of those vehicles and connect them to the grid during those specific, and this is an example, those specific hot, high demand days, and put power back into the grid, and you get the green line. And the thing that's interesting about that is that if you can flatten the net demand by returning some of that power to the grid, it has a huge benefit in terms of the need to build power generation plants, transmission, and every part of the infrastructure and all the environmental impacts that go with it, not to mention the economic savings. So this is a big deal in terms of how you plan the utility system of the future, having a type of load that is that much more flexible. So the benefits for the utility is this flexible or responsive off-peak load that you can charge at times more under your own control, and the potential to better fit that load or that demand to your sources of power, including clean renewable sources. This idea of vehicle-to-grid power could even return power to the grid when it could be of benefit to the utility. And finally, it's a way of reducing CO2 emissions, not so much that you would reduce the total emissions from the power grid. You would be using more renewables, but you would probably be using some more fossil power. But all of that energy is replacing petroleum use on the vehicle side. And one of the problems, if you ask utility, what's your biggest concern about emission regulations, particularly greenhouse gas emissions, is they kind of tend to get stuck holding the bag when the regulations come down from Washington, in the sense that you've got a limited number of big stationary sources, and let's put most of the emission reduction burden on them. That's how we tend to do it in this country. And the plug-in hybrid technology gives the utilities the ability to reduce emissions not just in their own backyard, which of course they're going to have to work to do, but also to find ways to back emissions out of the vehicle sector, which is typically much harder to deal with in the regulatory structure. So it's potentially kind of a win-win there. For the customer, you have vehicles now with better fuel economy, more fuel flexibility, longer range, better environmental performance. And by the way, I think John will point this out, these things will go. The combination of battery and motors and the engine will probably make these things like really hot rods. And John really likes that, I can tell you. So one of the things we're thinking about is creating a customer service package that includes charging your vehicle with 100% renewable energy that you can buy from the grid. Maybe adding a green home makeover to improve the energy efficiency and lowering the cost of operating your house or your workplace through energy efficiency and possibly solar installation. Perhaps a premium reliability service where you can be assured of power 24/7, even in the case of outages on the grid, and a package of financing and incentives to make the whole thing work. So in summary, this could be really a pretty attractive package for customers, including folks like yourself, early adopters. And even if you pay today's rates and pay the premium that you would have to today for 100% renewable energy, it will still be cheaper per mile to drive these vehicles than it would be to run today's gasoline car, even at $2 a gallon, even at $1 a gallon, actually. And so there's potentially a lot of attraction for the customer, as well as for the prospect of running the power grid more efficiently and accepting more renewables. And the environmental benefits here, the thing I want to stress is that it goes beyond just the performance of the vehicle. It enables environmental improvements and emission reductions, including CO2, in the other big part of the emission pie, which is the power sector. And to get all this done, as you can see, we don't have thousands of these vehicles driving around today. We need to continue to advance and to integrate these systems around high-performance vehicles, advances in renewable energy and power generation, and the design of the future grid, the smart grid that we've heard about. in ways that all of these technologies and systems work together for both economic and environmental performance. But the bottom line is a better deal for the customer, a lot of business opportunities for utilities and other technology suppliers, and hopefully a real coalescence of improving environmental performance along with their business performance. So that's the summary of my remarks, and I want to hand it over to John to follow on and really focus on the vehicle side. You turned on?
I'm good. I think I'm good. What's just so exciting about what Joel just presented, and I think you caught it, is that the two biggest energy users in our country, buildings and cars, and the biggest supplier of energy, which is the grid, are now beginning to merge. And this is what's going to flip the entire industry for us. Now all those users and providers of energy are all independent, and there's tremendous waste being provided everywhere, and emissions going to the sky, and energy becoming somewhat of a rare commodity. But when those things come together, as you're going to hear presented tonight, efficiencies can be gained, emissions reduced, and benefits will be gathered. I'm going to show you some complex slides tonight, and I'm going to try and simplify them. And Bob made me do this, so I'm just going to make him look good because his slides are really complicated. No, but I'm going to try and pull some things out of it. Put the man behind the curtain, please. Yeah, I've been in the automotive industry for about 20 years, and I've never seen such a perfect storm coming. And I think you'll see why in just a moment. On the left side here, obviously we've got a climate issue, we've got emissions issues, we've got oil becoming a rare commodity. And what this is causing is a grassroots movement in our country of increasing the electrification of the automobile. People are kind of understanding what a hybrid is now, that I can put electrons with gasoline engine and I get more fuel economy or better fuel economy. And oh, by the way, it gives me some creature comforts I didn't have before, because now I can potentially have thousands of watts of energy on my car that I could do something with I never had before. Maybe even plug it into my house when I have a hurricane and I lose my connectivity to the grid. So what you'll see here is what PHEVs do, what Joel explained. Plug-in hybrid electric vehicles is really like a Toyota Prius today with just more energy storage or a bigger battery, which gives you as a driver or consumer more pure emission-free driving capability. Okay? So 10, 20, 30 miles of pure EV range based on how big your battery is. But I can also, when I want to go to grandma's house on the weekend, I can go to the gas station, fill it up with gas, and I can drive the 300 or 400 miles that I need to go without worrying about it. So I have two infrastructures that I can leverage with a plug-in hybrid electric vehicle: the grid, electrical grid, and the fueling station. Okay? So that's a real simple description of that. And if these things are built, our government even says we'll buy them. So you've got a pull from the government, you've got a push from the consumer, and you've got, unfortunately, Detroit stuck in the middle figuring out what to do. And for those of us who have been in Detroit, it's a very frustrating place to be, but it's a marketeer's dream to have this kind of grassroots movement coming toward Detroit saying, we want this vehicle and we'll buy them. There's people signing up today. Let me try to explain a little bit what this is about. Going up the vertical axis here is efficiency in the platform. When I mean by efficiency, I mean by improved aerodynamics and lighter weight and less rolling resistance. So going on the road takes less energy to go down the road. On the horizontal axis, there are new vehicles being designed, such as the plug-in hybrid electric vehicle, and conversions of older vehicles into more electrification. And at the top of the efficiency platform is a program I was fortunate to work on, which was the EV1. And to my knowledge, it's the most efficient mass-produced platform ever made by a car company. It had the air drag coefficient of an F-18 fighter jet. It had 0 to 30 acceleration faster than a Corvette. It weighed 2,000 pounds without the batteries. Now let me give you an example. Maybe you've seen this lately in the news, the Chevy Volt right here, which is on the horizontal axis. This is GM's concept vehicle for a plug-in hybrid electric vehicle that was introduced to the auto show in January and got some pretty good accolades and some pretty good response by the public. This is a 4,000-pound vehicle. drag coefficient around 0.30. They forgot everything they learned on the EV1. So it's kind of, for me, it's a very discouraging concept, the fact that it's inefficient. Therefore, if it's inefficient, it takes more batteries to put on board. And batteries cost money, and you're not going to pay for them. So this is a concept that's not going to work. So until they start hearing the RMI message, really, of lighten your vehicle, make it more efficient, and then the energy you put on board is a minimum, then you can afford it. The cost equation does work. We're promoting at RMI, and we're actually working with a lot of the leaders in the industry for a clean sheet approach. And if you've seen Amory's presentation, you've heard about RMI over the years, this is not foreign information to you. On the left there, you see kind of a modular concept of putting a vehicle together leveraging advanced composites, advanced structures, putting a chassis together, a body together that may be revolutionarily different. In other words, I throw away my welding robots, I throw away all my lasers, I throw away my paint booth, and I put things together like you and I did maybe with toy cars when we were growing up in models. We also can develop lightweight structures for chassis and the things that people like to drive, road and handling and braking, and unitize, put those together as a system, as an assembly where you leverage componentry instead of having job shops or supply communities make those things independently and then hope they come together. This is the battery pack that I worked on for the EV1. And the only reason I put it up there is because it served multiple purposes with one product. Not only did it provide energy storage and power for driving the vehicle, but the tray that's on the bottom also unitized the entire chassis of the vehicle structure. So it gave it its road and handling performance, it gave its braking performance, it gave its crashworthiness performance, and it contributed to the lightweightness of the vehicle. So somewhere we're going to be resulting in breakthrough affordability and capability with a clean sheet approach that I believe our message is going, and I could talk to you offline a little bit more about some progress we're making there that we're very excited about. But it all comes down to this battery. And I know the battery isn't probably the most exciting conversation you're going to have tonight, but this is the key technology that's kept the electrification of the automobile from increasing. And there's three options today, and there always have been in the past decade or so. It's lead acid, which is what you have in your car today, most of you. Nickel metal hydride, which is what you have in your hybrid vehicle, if you drive a hybrid. And then there's lithium, which is what you have on your cell phone and your laptop computer. But the energy storage must meet three criteria. It's got to be safe, it's got to be durable, and I mean 200,000 miles durability, 15 years kind of durability. Okay, over the harshest environment you could ever imagine designing a product for, which is the road, in all kinds of temperature deviances and it's everything. It's just crazy. And then cost. Does it have enough value that you're willing to spend your money to get that value out of it? Which, by the way, if you replaced your cell phone battery, it's about $80. Most people, that kind of blows away how much you spend for a battery for a camcorder or for a cell phone. If you took those dollars and put it to a car, the battery pack would be about $800,000. So there's economies of scale here that just don't work. So when we get on a car, we really got to get cheap. And this is an eye chart, and I apologize, it's the last one, but I wanted to just show you a comparative matrix where the technologies are. And on the left side here, I have the battery technology, PBA being lead acid. There's an advance. This is where we are today. This is where we are tomorrow with lead acid. Nickel metal hydride, where we are today, and then where we will be. Lithium ion, which is where we are today and where we will be. And here you look at some energy densities. This is how you measure. It's watt-hours per kilogram. How many watts can I produce over time per mass? And you can see where lead acid is. This is, again, the battery you have in your car today. Produces about 30 watt-hours per kilogram. Tomorrow, maybe 50. For those of you driving a Prius tonight or a Lexus hybrid, you've got 60 miles or 60 watt-hours per kilogram. Tomorrow you have 80. Lithium ion holds the promise of pushing 200 watt-hours per kilogram. So you can see the doubling of energy density in this battery and how it gets smaller. I can package it. It's lighter, etc. And then there's some advanced lithium coming out that's extremely safe, but you compromise on energy somewhat. Cycle life, I won't bore you with this, but you can kind of see this matters a lot to warranty guys that deal with the numbers on selling a car, that it's got to work over the whole equation of the vehicle because there's this used car market that cares about used parts. And if your battery is going to go dead in the used car market, that's a $5,000 replacement piece, then the car will not sell in salvage or the auction, the used car auction. So you can see again where lithium, dropping to the bottom, is giving you a 15-year battery. So it's taking the cost, the warranty issue out of the equation. It's the highest value product you could have in your car. In fact, it's the cheapest battery that you can buy if you value life. Follow me?
Now you got my attention.
Yeah, that's good. The cost per watt hour, you see how cheap lead acid is today because it's been commoditized. It was invented back in the late 1800s. We spent a century perfecting it. It's 10 cents a watt hour. But if you go down to lithium, we're looking at $1 a watt hour. And again, if you value the life of the battery, the overall comparison can be equal because you see the lead acid doesn't last long. It's 500 cycles at best, 5,000 cycles for the lithium. So if you measure cost over time, it's a very compelling argument. I can talk to you more about that offline, but I just kind of want to give you a little idea of where the battery scope of the spectrum is and where things are coming. But there are safe lithium-ion batteries coming on the market, and I think you're going to be driving a car in 10 years that will have it and that you will be plugging into the grid. And these guys that follow me are going to tell you how you're going to do that with some of their products. So I'd like to introduce
Yes, sir. We'll be there. Yes,
Bob.
sir. Good job, John.
Good job, John.
Wow. Good evening. Can you tell John's a car guy? Can you tell he's an engineer? Amory's nodding over there. I want you to know, John. That's not a bad thing. Because when you're from Iowa, it shows. There's a story behind that. And can you also tell he's from Tulsa, Oklahoma? There's a little twinge there, isn't there? A little bit. Well, how about me? Can you tell I'm a gas guy? Does it show? There's some no's over there. There's some no's over there. Can you tell I'm an economist? I got an eyebrow. Can you tell I'm from Houston, Texas? Okay, fair. Thank you. You won't hold it against me. Some might. Some might. I've had somebody say that. I won't hold it against you when I introduce myself as from Houston, Texas. And by the way, welcome aboard, Michael. I'm thrilled to be here. I'm honored to be here. But if you get to know me, you'll find that I am the Pied Piper of biogas. I made the front page of the Wall Street Journal this year. There's a story behind that, too. But that's another topic, so I'm not going to talk to you about biogas. And he's supposed to pull me back if I go too far. But I am here to talk to you about PG&E's Smart Energy Program. Whether it's a cliche on a smart energy garage, and whether we're the first, I don't think we are. But I can tell you we are the committed. And I'm going to want you to keep two words in mind during this presentation. I think we can move to the next slide, and I'm supposed to have control here, which I don't. I got it. Oh, going the wrong way. Pardon me. God darn it. I'm going. I practiced this, everybody. I want you to know I practiced it. I think you are. Thank you. That was a good slide. I like that. Okay, here I am. So that's the first page. That's a little bit about me. Robert T. Howard. It is actually the second. Vice President of Gas Transmission and Distribution at Pacific Gas and Electric Company. One of the leading energy companies in the country, I believe. And I'm proud to be there. And as I said, there's two words that I want you to think about when you leave here. About how we can change the world. And that's bold and possible. So when you're listening to me, please, don't think about reality. Don't think about kilograms per square inch. Don't think about that. I'm an economist, remember? Assume a can opener. Okay. Bold and possible. So, imagine the possibility that your friendly local energy company, PG&E, we're the model, can communicate and identify any electric device on its system. Now think about that, okay? Today you plug it in. Do I know what device is plugged in? No, it's anonymous. I'm not going to go any farther than that. It's anonymous It's anonymous. Is it possible to identify any device that's plugged in on a grid? Absolutely. It is possible. We know it's possible. Well, why don't we do it? I think it's motivation. And I'm here to tell you that I think the time is now, and part of what's driving us in the utility industry is a concern that we do have a global climate change problem. So the Smart Energy Web links traditional and distributed energy resources. It is possible to transform us with a smart grid. That is by identifying what's on the grid at any point where it's plugged in. A plug-in hybrid parked at the Bay Area Rapid Transit System in Oakland, California, the parking lot there. Anybody that's parked there. You think BART's going to pay for that? No, they want you to pay for it. Should we have a station there? Would you rather have your credit card do it, or would you rather just link that to your PG&E account? You think it's possible? I think it's possible. Doesn't take much to do that. So that's really, isn't that transformation? That can totally transform the business to create the traditional utility into a smart, interactive, adaptive system. It links, helps customers, take a look at this, link transportation and utility markets. I'll talk about that more. Support the development of renewable generation. Spur energy management, spur innovation in energy management. And honest to gosh, it'll help end global warming. Thank you. So, Joel, it's not just a cliche on a smart energy garage. You know, it is smart. It'd be neat if the garage was smart. A lot of us like our garages, right? You know, sometimes we keep the floors polished and painted with enamels and stuff like that in the cars. But the real issue here is whether or not we can truly connect the grid with our values. And having that connect the grid, that's the secret sauce. Honest to gosh, that's the secret sauce. The battery's plugged in, it's interconnected with the grid. PG&E knows it's interconnected with the grid. Then what happens to the grid? All of a sudden, the grid becomes a battery, a very elusive concept that hasn't existed on any energy system, that is storage, exists. I can tell you something. Being a gas guy, it exists in the storage business. It's pretty helpful to us. It doesn't exist in electricity in an integrated fashion. And that's what makes it possible to end greenhouse, to manage global climate change. And it's not until we connect those values with our choices with our values that we'll really be motivated to move on. You know, there is a famous salesman, Zig Ziglar. Anybody heard of Zig Ziglar? My favorite quote. People buy what they want when they want it more than the money it costs. Huh? They want it. Because why? It has value. It's consistent. Doesn't matter what it costs. Joel was talking about a little bit of cost, and there are economic benefits of this, but are they doing it now? It is an $80 carbon tax today. Is it happening? No, we've got to connect this with our values. I'm going to do 2 quick slides here, and I'm actually going to skip this one. I'm going to go through it quickly. Oh, God darn it. This is so funny button here. I'm having fun. I know this is on tape, so we'll show this to my CEO. He'll love it. He's going to be proud of me, bumbling through these slides. All right. So if you look at it overall, if you just tie the transportation and energy grid globally, you can produce significant benefits in reduction of greenhouse gases by using that energy more efficiently. I can talk about this more. There's numbers behind this slide. But this is the more powerful slide. And now, I took a book out of John's page on these busy slides, but I'm going to show you one thing here. Now, this is what it looks today. This is what you pay for electricity. This is what you pay for gasoline, and it costs you almost $4,000 a year. And in that process of just traditional old car service and utility service, you are contributing 12 tons to the environment in an annual year. Now, if you do a few things here, like you do some you put a solar roof up here that can provide this many kilowatt hours during the year, you do your renewable off-peak car charging, you're going to reduce your gasoline usage, and you're going to reduce that, your total energy consumption is going to be less, or your total cost of energy is going to be less, $3,800. And look at this. What's the greenhouse gas contribution in that? 4 tons. 75% reduction. And I can tell you something. We're participating in this because we've financed all of this for you. And so we've generated earnings of $1,100. But what have we done? We've produced a savings in greenhouse gas consumption, a reduction of 75%. That floats my boat, I can tell you guys. I'm scared. So, when Joel is saying he goes to Kansas, and he goes to South Carolina, he goes to Texas no less, and they all think he's crazy for using examples from California. Well, that's what they say. That's what they said. But the real fact is that at this time, PG&E and California has led the nation in energy consumption. When we first read of Amory Lovins, and he's been involved in the beginning in California, prodding us along, I might add, but look where we are today with respect to per capita energy use. We lead the nation. So if anybody's asking, about what to do, you ought to take a book from our page, because I think that's the same thing we need to be doing and show that it's capable of doing with respect to greenhouse gas controls. PG&E is the first utility in the country to support greenhouse gas legislation in California, and we're extremely proud of that. We are leading the nation, so it's time for people to get on board. And the one thing that I might add, it is we are the only location in the country where when we are filling our cars with off-peak power, you are filling that not with coal power in the off-peak. Not that that's bad, we need it. We need it until we get our minds right, because in California you're filling it with wind. You're filling it with hydro. You're filling it with resources that do not contribute 1 ounce of carbon in the production of that energy. That's what we're doing. That's what you can say to the folks in Texas. That's what you can say to the folks in South Carolina. That's what you can say to the folks in Kansas. Because that's how you're going to see that potential emerge. We intend to lead the industry in managing greenhouse gas emissions as a company by aligning our corporate values with our customers' values. We will delight our customers. I can assure you by the work that we've been doing on this strategy, we are engaging our employees. They are thrilled at our leadership in this area and passionate about it. And I believe we will reward our shareholders. This is bold. This is possible. I thank you for your time tonight.
Hi, everyone. I'm the last speaker. It's a great pleasure to be here, actually. And what I'd like to do is provide, again, a little commercial perspective on this. I'm going to ask you not to dream so much, because to a certain extent, I think a lot of this might be closer than we think. So I'm going to talk a little bit about our company and sort of our involvement in this space and share with you our vision. I was watching very intently, because this is the first time we've seen the slides. We all came together fairly independently, and I think you'll see a lot of commonality between the messages that we have. A little bit about Johnson Controls, a pretty old company, 122 years. We were founded by Professor Warren Johnson, who invented the electric thermostat. So we've kind of been in the energy and conservation business for an awful long time. We dabbled in vehicles in the early teens and 20s, like most companies did, get out of it, and then got back into it in a big way a little bit later. We're a successful company. I think some of the data shows that. And we've been successful because I think we picked the right technologies and the right industry trends. So we tend not to do foolish things, and I think the reason we're here is because we think what everyone's talking about today is very important and something that will, in fact, have a big impact. We have 3 businesses, and I think it's pretty obvious why we're here, because all 3 of our businesses line up perfectly with the presentations today. Oops. Yeah. Thanks, Bob. I'm not an economist, I'm an engineer, so I should be able to work the technology. Largest business is automotive interiors, very large market share. Most of what's inside a vehicle is made by Johnson Controls for all the major automotive manufacturers. We also make electronics, which certainly provide communications within the car and the sort of out-of-vehicle experience where you're communicating with your home and back to the workplace as well. Perhaps the most important, I mean, we heard John say it's all about the battery. Well, the good news is we're in the battery business. We make an awful lot of those lead-acid batteries that you might buy under the trade name of Interstate or Pep Boys or Walmart or things such as that. But the really exciting part of the business and pertinent for today is our work in hybrid battery, both nickel metal hydride and lithium ion. We have joint ventures in Europe and are actually progressing very, very quickly in that area. Very exciting. The building efficiency business is the part of the business that I'm from. It's the oldest part of the business. We make systems and equipment. The smallest part of our equipment business is one that's actually fairly important to many of you. We're the world's largest manufacturer of snowmaking equipment. And in fact, so this was sort of a job site visit for me. But all the snowmaking automation on Ajax Mountain is actually provided by York, which is part of us. Now that's a small, but my favorite business. Most of it is in the area of automation systems and chillers and heating and cooling equipment for homes and offices. We also provide a lot of services through 10,000 frontliners around the world. And my other favorite part of our business is building efficiency. From the period of 1990 to the year 2000, we saved $17 billion worth of energy for our customers. Now, that's an awful lot. That's why, frankly, they invested, was to save cost, but there is a side benefit. If you look at what that translates to, it's 166 million megawatt hours of energy savings, 2.5 gigawatts reduction of electrical demand, and 217 million tons of CO2. Good news is that was 1990 to 2000. Just calculated it. The first 5 years of this decade, we've actually matched that. So we're actually doubling up on the rate. So something we're very proud of. Now, these businesses are very, very different, aren't they? It's 3 businesses united by a common sort of letterhead in many cases. One of the things we share is a focus on sustainability. PG&E certainly has a lot to be proud of. We think we do as well. We're listed on the Dow Jones Sustainability Index. We tend to be leaders in very specific areas like recycling 98, 99% of all the lead-acid batteries, right? Reducing the weight of components in automobiles, which you heard is so important to improving their efficiency. And of course, our energy conservation efforts certainly have a lasting impact on our customers and the planet. So that's something we're very proud of. Now, these are 3 very different businesses, all of which are impacted by the topic tonight. In fact, we played rock, paper, scissors to see who would come, really, right? I'm thinking Aspen, March. I was reading Emory Lovin's papers when I was in college in the late 70s, and Ajax. So I luckily won the rock, paper, scissors and got to present. But I must say, we could have had individuals from our company. Dave is from the automotive group, and our general manager of hybrid batteries was dying to come out as well. So all areas of our company are very excited. Now, let's talk a little bit about kind of how it all comes together. We use the SMART word as well. Ours would be smart environments. We say that what we like to do is provide comfort, efficiency, safety, and productivity for anything with 4 wheels anything with four walls and the four corners of the earth, all right? So that's kind of our domain, and we want to really bring those customer values there. What's very interesting is we had some interaction between those areas, but it was only until we really made that connection to smart infrastructure where we could bring in a systems view actually back to the grid that we really found the true synergies here. This is a picture we like an awful lot. It's from the Electric Power Research Institute, a friend of ours, Hank Courtright, and we think he just nailed it. In fact, the whole right-hand side, I think, of this diagram looks like our strategic plan, because we really touch all of those particular elements, from the plug-in hybrid to distributed generation, our work in renewables like solar and wind, smart end-use devices, those would have our name on it, at least in many cases, as well as the automation systems that go on the building. This is a perfect vision, I think, of where technology can enable some of the benefits you've heard today. So how does this work? Essentially, as soon as you start working with the utility, there are a few things that we've actually been playing around with for many, many years. I remember back in the late 80s when we did a pilot project with the Southern Company in Georgia where we retrofitted 300 homes with a very special little thermostat. This thermostat would get called up every night by the utility and it would be given a price profile for the next day. The homeowner would go in and it would say, okay, if the price is this, I want the set point to be this. If the price goes up to this level, I want to turn off my spa pump, right? And oh boy, if it's a very critical tier, I'm going to shut a bunch of things off. It was very successful. It was old technology. Imagine what you could do today in the world of TiVo, right? We think nothing of letting lots of folks actually talk to and from our house. So, and of course in the commercial building space, been a lot of work with real-time pricing, the utility telling you to turn on your generators to help them load peaks and things such as that. If you take it to the next level, if you bring it to the home, some really exciting things happen. Obviously, that network is going to recharge your plug-in hybrid. It's going to do it at night when rates are cheap. You're going to be able to use that energy. We increasingly hope you have solar and other renewable sources that you can run the electrons into those vehicles. And then there's the idea is perhaps you can share some of those electrons back to the grid. Or maybe you just want to use it within your own home or your own business. I think there's some other models which are very attractive, which would be, for instance, instead of just turning off your air conditioner, right, when we have a very hot day, maybe you use the battery for a couple hours. If you actually run the engine in your hybrid, you could get a couple days worth of backup power. Now, isn't that interesting, right? And you could do it in a very efficient way. Sort of like a Generac on wheels in a way, right? You're using that investment for multiple purposes, all right? And I'd just like to end with one kind of visionary slide. We love this slide. The lights are just low enough here that I think it's very attractive. Imagine that investment that you make, or one, hopefully two vehicles, plug-in hybrids, and imagine how you're making advantage of that investment in advanced battery capability. I'm not only using it to drive back and forth to work without running the engine, right? I'm storing energy off-peak into the battery. I'm taking advantage of renewables if I happen to charge that energy. I might be taking advantage of that during high-demand parts of the day. The utility, I'm sure, will reward us greatly for doing that. Right, Bob? What was that? Yeah, reward us greatly for taking advantage of that. And in those unforeseen but increasingly frequent situations where the grid lets us down, this is a great view, right? Imagine being able to, for hours to days, being able to use that investment you've made to basically run your house there. And not that we want one house to benefit over the others, but hopefully this is a vision that would make it seem very attractive to you. So we are very proud to be here, actually. All three parts of our business hope this works, and we're very interested in working with RMI to basically bring these ideas to the marketplace so we can all benefit. Thank you very much.
So I think we're going to bring everybody up and we'll have a question and answer period.
Okay, so yes. John?
You mentioned plug-in hybrids. There aren't too many of those yet, but hybrid vehicles have been optimized for stop-start duty cycles. So they're great in the city. If you could, the same engineers, if they wanted to, could optimize those for highway, but right now, because of the limited battery storage on board, you can't really optimize for both. But a plug-in hybrid potentially could alleviate some of those problems.
Yes.
GM says you can die in 2010. I'm not sure I believe that, but there is some scuttlebutt around Toyota that they'll be hitting that target timing as well. But I could sell you one right now.
Well, there are conversions which are kind of kludges available today. I wouldn't say on the market, but it'll be a while for mass-produced.
It all revolves around that battery that we talked about. So when that battery's tested and proven and cost value comes down, then they'll come out. And all I can say is beware of Toyota.
Yeah, excuse me. Yes. Question is, diesel electric hybrid a possibility? Yeah, let's.
In the heavy-duty vehicles, Freightliner has produced a beta prototype of a heavy-duty bucket truck that's a diesel, and that's in partnership with Eaton, and that they're basically beginning what I call a first production run of about 30 trucks a month, beginning in July of this year, and then they expect, depending upon demand, to go into full production offline. So you're definitely getting certain applications, and from the utility perspective, we're vitally interested in those kinds of applications.
Can you hear okay? Is the mic working okay?
Can you hear me okay? One more comment I wanted to add was that what's exciting about plug-in hybrid electric vehicles is that the optimized powertrain is around the electric motor and the battery. And the supplemental powertrain is around the internal combustion engine, whether that be gasoline or diesel or biofuels or flex fuels or fuel cell in the future. So you really optimize yourself for whatever great combustible technology comes down the road is going to supplement the clean, efficient energy of electricity already.
Could also be fuel cells.
To the earlier question about when can you get a plug-in hybrid, there's an organization called pluginpartners.org. You might just go sign up. I mean, PG&E has been promoting that campaign, and the purpose of that campaign is to make sure that, is to really send a message to the automakers that our customers want them. And so when you look at it from PG&E's perspective, if 5 million people that are our electric customers are all signing up at that site, we're using that information to tell them we want plug-in hybrids now. So it's www.pluginpartners.org, and tell them PG&E sent you.
Amory had a question.
it's in the vision. It's not in our current financing, but absolutely. I mean, there's two things that drive us toward that. One, Clay wants a reward, and we want him to have a reward. And all of us want a reward, because that really does make, if it really fundamentally changes the dynamics of the renewable portfolio standards that are out there today. Imagine now, the utilities are out buying wind power that's only available at night. Now, if we can multiply the use of that wind power if we put it in a battery, and then we deliver it as customers in the afternoon as a peak energy resource, and it is tagged as a renewable resource where it's needed. And you've said it. I think about it this way, that every day we're driving in cars and we park them in a parking lot for most of this country, and that's just latent energy that's wasted that could be put to use. It's just its own little power and distribution system, all its own for one or two people, every day, that's sitting there that could be put to use. And that's the power of this. The second point is the battery. And the fact is that, as you saw in the slide on the reduction in greenhouse gases that I showed for the personal at the household, the fundamental premise there is that, for the utility to cannibalize itself, what's our investment opportunity? The investment opportunity is we're investing in the solar panels for that house to create the smart garage. We're financing that. We think about it the same way for the batteries, if we can get to that particular point. At this point, the life cycle of the battery that's in the car, its duty cycle is not going to last as long, but it still has use after it's retired from a car and that car is recycled. And it could be that batteries or that package of batteries could be taken to substations, for example, and their duty lives would be extended for significantly longer than it was able to be used in the car, and it would increase our reliability. And then the third part of it is the recycling aspect. We want to make sure responsibly that we're taking care of the full cycle of that battery. There are more batteries that would be produced as a result, and all of the things that go along with that need to be managed from the whole life cycle, from beginning to end. And so we think that there is a role for the utility to be involved in providing that life cycle.
There's actually one interesting, at least conceptual precedent for this. When Big Freeman was running the Los Angeles Department of Water and Power, he had the interesting idea, why don't we have fuel cell buses, which are all around.
Right.
And when we use them during the day to clean up the air, and to breathe better and to get paid for it,
Right.
because the NOx market is
Right.
and the Department of Water and Power, the utility, would own the fuel cell and lease it to the
Right.
bus part of the transit system. Then at night, when the bus is in the barn, we would use it as a stationary utility generating asset, reverse the power flow we were importing from the Pacific Northwest, for example, sell it back to them, and they can use it to keep more water, dam the good water back to the salmon and salmon season. Or during the summer, we would use it to displace coal power, say, in Arizona, and get a carbon credit for that.
Right. I think the key to the fuel cell is the production of hydrogen. And I know you're well aware of the fact that 95% of the hydrogen that's produced in the country comes from natural gas today. That's how it's produced. And so we have to crack the nut of efficiently producing hydrogen with the energy requirements that it takes to do that. That's why when we think about the marriage between plug-in hybrid electric vehicles and the power grid, it's something that's available today. It's something we can do now. Continue to build that bridge to generating a resource where we can have emission-free power sources like fuel cell that can produce at the capacity that we need to have an impact on greenhouse gases. But fundamentally, we can crack the greenhouse gas code today through batteries, but it's the same concept. We've got to manage the life cycle. And there's nobody, look, we look from your perspective. We are in the life cycle business in nuclear power plants. We are absolutely responsible for them from the beginning to end. And that is, in the public interest and a social responsibility. It's the same when we're talking about batteries. We've got to look at this from the life cycle process and apply those principles that have been applied to how we've been able to develop other resources and be responsible for them from the beginning to end with the development of batteries. So we think we should consider being in that business, although we're not there yet. As you saw when we announced our earnings this year, I mean, clearly our chairman, Peter Darby, said to the financial community that this is our strategy. We're moving forward with this strategy. This is our strategic imperative. It's not about mergers and acquisitions per se. It may happen, but it is about building this strategy and a vision of making this happen in a responsible way.
Let's go on with some other questions, please. Yes.
Sorry.
That's all right. No, it's good. It's good.
What role is the government playing in stimulating or incenting this vision? And do you think that's adequate? If you don't, do you think it should be playing more role and more way?
The question is the government role in providing incentives to achieve the vision that we've been describing.
I think they've certainly been involved in some of the basic R&D. There's been a lot of R&D, and batteries are the most important thing. So there's been a lot of sort of investment in battery research, generally with the private sector, which is good, right? That shortens the path to commercialization and keeps things real. I think the other half of your question is probably more about incentives and regulation and things such as that. I think there's a lot that can be done there. I'm probably not the best to speak about that. You probably are, briefly. Right?
Yeah. Thanks, Clay.
Was it emphasis on the briefly part?
I mean, on the incentive side, very little is being done. That's the simple answer.
If I could add to that, one thing to point out, people are not necessarily familiar with the electric power business. Most of the regulation of the electric power business is actually done at the state level. And so there's a vast difference between states like California, that's very progressive in these areas, and a lot of other states. And Colorado, frankly, isn't a leader, although I think we're going to see a lot of changes in the coming new commission. And so in states that have motivation in the state government bodies, the utility regulatory commissions in particular, you see really great things, such as PG&E is doing in California, some of the other states in the Northeast and the Northwest in particular. But I think in order for these things to be really taken forward, we do need more federal action. At the very minimum, we need some kind of a signal on CO2 emissions, whether it's a cap and trade program. People have talked about a carbon tax. I don't think that will happen, but some signal that there's a cost to CO2 emissions. We need further and really nationwide power sector regulation of the sort of thing that's going on in California as well. Yes?
You brought up an interesting concept of making an intelligent grid, where you guys are now on the grid. Is there some tie-in to efficiency with that intelligence?
Question is there an efficiency benefit of the intelligent grid as well?
Absolutely. I mean, you're maybe aware that PG&E is investing significantly in an automatic metering initiative, our smart meter, another smart. And a part of this is around, being able to communicate with appliances. So it's not just the battery and the plug-in hybrid. As you see when I showed the third slide of the distributed energy resources, solar or wind or and that small wind and other aspects like that, smart appliances and things like that. So the effort is to have that communication there that people, can receive signals. Today, all of that is happening, through wire communication and current technology, but it can be more interactive.
Yes.
I wonder if there are batteries and power sources being researched that do not depend on chemical electric systems.
The question is, are there battery technologies that are being researched that are not electrochemical technologies?
There is. There is a company right now that's kind of getting some press called EE Store, which is a capacitor-based technology. Typically, with supercapacitors or ultracapacitors, these are called, what I showed before, the energy storage capability goes way, way down, but the power to deliver energy real fast is very good and superior, actually, for cycle life and some of these things we've talked about. But there's value trade-offs there between energy and power and cost and all those kind of things. But there are non-chemical solutions being pursued. Yes.
Questions about the safety of battery technology.
And do batteries get hot and blow up? Yes, the answer is yes. Every battery engineer has blown up a good battery. So there's a chemical, even the battery in your car, and of course it should be noted as well, your gas tank can blow up as well. But really, don't worry.
And now for the good news, folks.
Everything's fine. But without going into a whole lot of detail, lithium-ion per se has made a lot of news. Last August, the largest consumer electronics recall in the history of mankind was performed on lithium-ion batteries for laptop computers. And there's just a fundamental flaw in some of the design there, but there are designs coming that remove that failure mode. And so there are solutions to that. And again, engineers that design these things, believe me, as litigious as this country is and wanting to sue big companies, we take everything we can to prevent any kind of failure in the workspace. And I'd like maybe JCI to address that as well.
Yeah, my biggest struggle coming from the interior side is trying to keep the cost down of the battery. And to do that, it's the light weighting aspects that we can bring. So I see Amory's got a little bowl in front of him, the Fiber Forge. Bringing new technologies and new material science to reduce the weight of the overall vehicle and the interior will contribute to the lower cost of the battery. And safety.
Yes, here. The question is the grid infrastructure that we need, and is it happening, and how long will it take?
It's happening. There's research that's underway right now with vehicle-to-grid technologies, and part of the research that has to happen is to look at the interaction with more and more distributed resources. PG&E, at its Technical and Environmental Services facility, has been researching vehicle-to-grid integration with distributed gen and other things that for the last 15 years. I think we're ready to apply those technologies, and no, I'm not a politician.
Yeah, if I could comment on that, I think it's similar to some of the other issues where you'll see really differences regionally. In states like California, where you have a relatively progressive regulatory environment, you have companies like PG&E that are really trying to push these technologies and improve their environmental footprint, and you have customers, and you have an investment community that's entrepreneurial and willing to bet a little bit on the future technology. You'll see much more rapid progress that will spread to other regions, and I think you'll see a pretty big difference for a few decades still. Yes?
My question is, you said a Prius is optimized for town travel. And I do a lot of trips to Denver also. Is it possible to design something so that when you're driving in town, you put the switch to the T, and then when you're driving to Denver, you put it to driving to Denver, etc.?
Can we get his resume and just sign him up to RMI?
The question is it efficient to drive downhill? And the answer is yes. Until you have to go back up. Okay. We're running short on time. I'll take one more question. Dave, you want to address that? Yeah. Question is the automotive industry embracing new materials?
Yeah, certainly the advanced composites that Amory has, biopolymers are in a growth mode right now. It's part of the renewable aspect, using switchgrasses and you know, corn or sugar-based.
You're talking about fuel, but what about the materials to make the vehicle itself, the lightweight materials? Do you want to address that?
Well, certainly aluminum alloys, magnesium, lighter weight plastics, reinforced plastics with fibers are increasing in our industry, and investment in that is on the increase. It's the big challenge that always comes back to cost, and that's part of the equation, that the more demand there is for these more fuel-efficient vehicles by the general public casting their vote to put the pressure on the OEs and the suppliers, the more we'll have in our bank account. Thanks.
It's www.pluginpartners.org.
Okay, I think we'll wrap up there. Thank you so much. We have a nice hors d'oeuvre and wine reception.